This is a simple video about building a simple motor. A simple motor is a coil of wire supported by something and given a power supply, and the coil of wire turns round and round and round. Usually we use motors to do work. This motor does not do any work. We're just demonstrating that it goes around and around and around. This is that same motor, only a little bit of picture of it. I'm going to stop it, and we're going to take a look at what's happening in general here. We've got a coil of wire. The coil of wire is being held by this safety pin here. So it's going through that safety pin and coming around. Now they actually wrap the coil a little bit to make it sturdier, and then from that wrapping it goes around. So we've got one turn, and a second turn, and a third turn, and a couple of more. And then they wrapped it again to make it stable and bring the other end of the coil of wire on out through here. Now the side that's facing you, if you notice it looks all gold and shiny, that's because they've stripped the insulation off of part of this wire. We'll talk about that some more later. Here we have a power supply, and so we've got little electrons moving up through here. Electrons move through the paper clip onto the wire that's had its insulation partially stripped off, and the electrons move this away. Down here we have a magnet, which creates a magnetic field. Magnetic field's going up like this. The electrons are moving this way at the top of the coil, so that creates a force going into the screen, so that kind of pushes our coil that direction into the screen. Down here the electrons are moving this way, which creates a force that pushes the coil out of the screen, which again makes this guy go this way and this guy go this way, and makes the coil turn. Eventually the electrons get out of the coil and come back through here, and then go down through the paper clip and back into our ground of our power supply. That's the theory. The theory is really very simple, which is why it's a simple electric motor. What gets complex is some of the engineering. You have to get the engineering correct in order for the motor to work. So we have a simple science theory, but you've got to construct it correctly so the whole thing goes. And there it is, going rather nicely. So to build this, we're going to need some large safety pins, some magnet wire, a couple of magnets, a DC power supply, a way to connect the power supply, tape, scissors, sandpaper if you want it. I'd rather not use it. And it's helpful to have a cylinder to roll the wire around. Again, we have our two safety pins, and as noted, it's the bottom end of the safety pin is what the wire of the motor will go through. So you want that bottom end of the safety pin sticking up. I found it easiest when I made the holder to actually use my magnets. So whatever you use to make the holder for the motor, the two safety pin ends should be reasonably level. And I'm a real klutz, so for me it's hard to get them level. I always end up having to adjust them later on. With the magnet I made them close, and then I taped them down so they wouldn't move around too much. You also have to remember you need to attach the power supply to them, and you need to be able to fit the magnet between the two safety pins, which I solved by just making it the magnet themselves. After you get the holder made, cut off some wire. The exact amount isn't terribly important, about a forearm length or an arm's length worth, about 30 centimeters approximately. And then you're going to wrap the wire around something. Usually you want to get several coils. The more coils, the more powerful the motor is going to be. You don't want to make it too heavy though, so you don't want too many coils. But make some, and you leave about 2 inches of end on either side of the coils. Then take your coiled wire off your wrapping form and make it into a neater coil. how do you make it into a neat coil? Well, first you hold it there, and then you take those free ends of the wire and wrap them around the coil. It's hard to see here, but I've got this end wrapped around here like this, and then it comes out. And over here I have this end wrapped around here like this, and then it comes out here. That makes it these coils stay neater, and also I managed to get this out about halfway, so I've got half the coil above it and half the coil on the bottom, so it makes it more evenly balanced. Here I've got gold magnet wire, and it's a little easier to see because this is heavier wire. You can see the coil here, you can see the coil here, the end comes out here, you can see I've got a coil here, I've got one coming out here. And you can tell about half the circle is above the end piece and about half the circle is below the end piece. Again, here's just another picture of it where it's easier to see the neatness of the coil. And another picture. I was proud of that coil. After you've made the coil so it's reasonably neat and reasonably well balanced, I go ahead and check the coil in the holder to verify that it really does balance. And I adjust the length of the ends to make it easier to get in and out of the holder without destroying the coil. This video shows you how I cut the ends off so that I can just kind of slide it out without having to bend the ends too much. That way I don't mess up with the shape. Here's where some of the engineering comes into play. If you take a look at this picture, you can see that my safety pins here weren't terribly level, but it looks like my coil really is. This is that gold coil, which was heavier wire, and it's not sagging anywhere. I've got the safety pins close enough together, the holder, so that the weight here isn't bending these wires over here. So the only engineering problem I have with this particular picture is the fact that this overall setup is not terribly level, so I have to adjust my safety pins a little bit. With this view, you can see that I've managed to adjust my safety pins so these guys are reasonably level, and you can also again see how this particular coil is fairly evenly distributed, where about half the weight is below the center section and half the weight's above. So it's going to rotate nicely. These ends are straight and they come right out. They aren't bent. They're free to rotate. Now there is extra material here, so it's not going to fall out easily. So I've got, a bit of extra material sticking out. So these has wobble room to wobble back and forth. But these ends are not bent or crimped or anything like that. Bad idea. This green loop, nicely balanced, but you can see it sags down in the middle here, so it's got a slight problem with the sag there, and I have to take it out and straighten it up a little bit. It might be that sag's okay, but you just gotta play with it a little bit and see. Again, I've got these straight ends at the end. This end doesn't have as much room on it because it makes it easier to get out. This room I've got a lot of extra wire. It's just the way I made my green coil. Once you get your coils reasonably neatly made, somewhat level and balanced, okay, not perfect, but reasonable, then you're going to lay the coil down on a note card or a heavy piece of paper and scrape the insulation off of both ends on one side only. Both ends, one side only. Scissors can be used to scrape off the insulation, or you can use sandpaper. I actually find the scissors work easier than sandpaper. So what do I mean, both ends? This guy is going to get its insulation scraped off. This guy is going to get its insulation scraped off. But then I'm going to turn it over and leave it alone. Likewise, I'm going to scrape this insulation off and this insulation off. I'm going to turn it over and leave it alone. I want to go up reasonably close to the coil, but not so close that I damage the coil itself. So, again, you want to get reasonably close, depending on how talented you are. That's why I find the scissors actually are easier to control than the sandpaper. Here I've got the insulation stripped off, both ends, okay, on one side. So one end on the side that's facing up only. If I turn them over, you can see easier on the green one that there's no insulation taken off of this side. This side has been left alone. Over here on the gold one, I actually used a purple permanent marker to apply insulation back on it. So this side, both ends have been left alone. This side, both ends have had the insulation taken off of it. No insulation? Insulation on this side, both ends. Now you're really ready to set the coil in the holder and fine-tune any other miscellaneous engineering problems that might happen. Again, the theory is simple. Engineering, though, always takes a little bit of fine-tuning. So here I've got my green coil, and I start up, and it looks like it's going to go really good, and it just, but then it goes backwards. And actually, that looks pretty good. But then it slows down and stops. And I try and start up again. I move it around a little bit, and I get it on, it stops again. And I start up again, going the other way, and it looks like it's pretty happy actually. But no, it's not. It's starting to lock up there. So I move it a little bit because the insulation might not be off quite so well on one place. And I start up again, and it looks really, really happy. So it keeps going. Pretty nice. Real nice. I'm okay with this. The gold one's even happier. It just keeps right on going and going and going. Another shot of the gold one. It's golden. Side view, you can see again those little ends are free to rotate. They bounce around some, but overall they're free to move around. Here I am working with that green one again, trying to get it to go. And there it goes. I find it easier to nudge it with a pencil than with my finger, because I'm less likely to hurt it. And it's got some problems. I've got to scoot it over again. The green one, oh, and it's locking up. And it's kind of dancing. Give it a little bit of a move. And there it goes. Again, notice that this is really fairly straight right along in here. Doesn't have to be, but it's helpful. If you notice while this is turning, it's easier to see with the green. You'll see that part of these ends are still green, and part of the ends have had the insulation shaved off. Also, you'll notice that for some reason, because of the way the insulation is, or the way it's bent, or whatever, it's happier when it's over here closer to this particular safety pin. It's just the way this guy ended up being. So I hope you have a golden motor moment also. Thank you very much for your time.